Okay. Everybody, to the Bhumandal talk series, we have an exciting talk today by Mr. Ujaval Gandhi, who is with Spatial Thoughts. And I'd like to welcome Professor Dayasagar of ISI Bangalore to introduce the speaker, and then we'll get started with the talk. And I'd like to request everybody to post questions as we go along in the chat or in the Q&A ideally. And we'll take the questions by the end of the talk. So enjoy the talk and off to Professor Dayasagar. Thank you.
Yeah, good evening, everybody. And it is such an exciting day today, particularly for me and Saroj. And we have a heavy day also. The morning there are a series of talks. But it would be nice, it would be very refreshing to hear our speaker looking very young on such on a topic Google Earth Engine for planetary scale decision support. It's indeed a very interesting topic, and to see his background, and he has a very solid background in uh, geographic information science, and then he had his master's degree from very reputed University of Wisconsin Madison, and subsequently he joined Google and moved back to India in 2006. And he was indeed, yes, one of the early employees at Google India. And Google Maps was so successful. And I always used to compare that there was an Apple Maps, and which was eventually a failure. Though they announced that Apple Maps was so successful, and then eventually they apologized. But Google Maps was very, very successful, and he was the part of Google Maps, but it is also rather curious to see why Ujaval has left Google Maps, and we have to listen to him. And he started his own company, Spatial Thoughts. Spatial Thoughts is very interesting, particularly in America. They wanted to start from the schooling level that there should be a spatial thought. The way mathematics was taught to the students and kids, and the spatial thought and spatial thinking is very, very important. And he worked on multiple geo teams at Google and led the GIS team in India. He was also the lead trainer for Google Earth Engine in India and trained over 1,000 researchers, scientists, and engineers. Yes, indeed, he is a world-renowned GIS expert. Otherwise, he would not have been in Google. And then subsequently, yes, he left Google and he started his own startup for spatial thoughts. That is building a learning platform to bridge the skill gap in the geospatial industry. And he publishes widely used open learning materials on QGIS and Python at QGIS tutorials. And he is also a visiting faculty and researchers at the University of Johannesburg, South Africa, and lot of interest, particularly your the spatial thinking and spatial thought. And let us all welcome Ujaval Gandhi to deliver his talk on Google Earth Engine for planetary scale decision support. Please, Ujaval.
Yeah. Good to have.
Thank you, sir.
Thank you, sir.
Thank you, ma'am, for the warm welcome and kind introduction. I'm really excited to be here. I'm a new IEEE GRSS Bangalore chapter member, so really excited to work with you all and do more events such as this. So I'll get started. We have a long talk. To cover multiple topics. The idea for today's talk is that I'm going to talk about Google Earth Engine and why it is built, what it can do, how you can possibly leverage it for your work. I'll show demos. I like to have talks that are more interactive and live. So I have a lot of demos which I'll show how you can access Earth Engine from a variety of platforms, whether you're using QGIS or Python or JavaScript. And then I have a series of applications which over time will have built and used Earth Engine, and focus will be on applications for India. And then at the end, I'm going to talk about, if you're excited about Earth Engine and you want to learn, I'm going to share some of the resources and methods that you can use to learn and adopt this platform. And I'm going to also show you, if you're interested in teaching Earth Engine at your university, I'm going to share resources and we'll take questions at the end. But as I'm talking, if you have questions, please do post them in the Q&A chat so you don't forget. And we have plenty of time with them, so I'm going to go through all the questions and answer that. Sir already gave me a very long introduction, so I'm not going to spend much time on that. I want to kind of focus on that I'm actually a civil engineer by background. And I was at BITS Pilani, and I had no idea what remote sensing was. And then I got this internship at Indian Institute of Remote Sensing. And this really opened up my eyes to the whole world of Earth observation and what it can do. So I really got fascinated from my time there. And I attribute a lot of the things I learned in my career to my time spent there. So I'm really grateful to the faculty members there and the setup that helped me choose this as a career. I was lucky enough that after I finished my master's, I got acquired. I was interviewing with this company called Keyhole, which finally got acquired by Google, and that's how I ended up with Google being a GIS person. And this was in the early days, and I got to experience the whole shift in this industry, where Google Earth was not there, Google Maps was not there anymore. From that point to today, where Google Maps and Google Earth and satellite imagery is ubiquitous. So I was lucky enough to witness that, and I learned a lot from that experience. And I was always interested in teaching and training and skilling people. And what I learned is that the skills that I learned at Google are kind of unique, and they are kind of what people currently need in the industry. And those are the skills that are missing from our universities and our teaching establishments. So that's what my mission is with my own company, is to bridge that gap and help people learn those skills. I hope this is better. I got a comment that the mic was not clear. Let me know if this is a little better. Okay. So
This is good.
Okay. So I recently left Google in this March, and I'm focusing on doing short trainings to help people learn programming, adopt open source, and adopt platforms like Google Earth Engine. So when you look at Earth observation, a lot of you might have worked in this area. You might have used remote sensing and Earth observation data. And you might realize that if you are trying to address any of these global problems, and these are just a handful of problems affecting our planet currently, whether you take deforestation or managing our water resources, you tend to realize that as you start working on solving this problem, to make any meaningful progress, you need to work with really large data sets. And all these data sets, for example, for climate change, they are all interconnected. So you really need to work, even if the problem is local, you need to work with national global scale data sets. Even if problem is kind of local, so you're trying to deal with something in your region, still you need to work with deep time series data. So again, you need to have access to all the historic data as well as the current data to make sense of it. You also need to combine multiple data sources. So you are taking satellite imagery, you are combining ground data, you're taking GIS data and trying to build into and trying to query that. And that poses a lot of problem with the traditional workflow. So this is a big challenge for scientists who are working in this domain, that to make meaningful progress, you need to work with these large, challenging data sets. And if you've done any remote sensing, you know this is how our workflow looks like. And this is certainly what my workflow looked like before, where I spent a huge chunk of my time just preparing data, downloading, processing, doing data munging. And then I'm left with a very little time to actually do the real interesting work where I want to analyze and derive new insights. So can we do something where the data prep is something that is common across every workflow? If you're working with satellite imagery, you can download it, process it, do atmospheric corrections, do reprojections, all of that. You may need to remove some missing data, etc. All of that, you can just do once and make it available to people. And this is known as analysis-ready data. So if you have analysis-ready data, then the scientists can really focus on querying this data and deriving insights out of it. So this is the kind of vision where can we flip this workflow and say we do all the kind of data munging, data downloading just once. You don't, as a scientist, you don't need to worry about that. You just spend your time doing real science. So before we start, let's just clear up some terminology. You might have heard of Google Earth. Google Earth has been around for a long time. And this is the 3D viewer for high resolution imagery. And this has been around for over 15 years. You can download on your desktop, or even visit on your browser. You can explore the whole world's high resolution imagery in really rich detail. You can do it in 3D. But this is just a viewer. This is targeted at users who want to explore the planet, learn about it, look at their homes, look at their surrounding area. Google Earth Engine was kind of built on top of that, was inspired from that, but it's a different system. Google Earth Engine, what we're talking about today, is actually a cloud platform built for remote sensing. It is built by scientists for scientists. So it's a very kind of different product. Probably the only common thing between these two are the name. Otherwise, it's a kind of very different system. And we're going to learn more about Google Earth Engine today. So as I mentioned, the Google Earth Engine was inspired by Google Earth. And this is a screenshot from Google Earth. When Google Earth was launched, what people started realizing that there was this historic imagery viewer. You could actually go back and check the high resolution imagery collected over any area and explore that. And there are people who are interested in tracking deforestation. This is a screenshot from the Amazon rainforest. And what they saw that as you go back in time, you can see that this pristine rainforest was encroached and this whole land was deforested over the course of 20 years. And there was a lot of demand saying that, can we have a tool that allows us to monitor this more in real time? Can we have this tool where you can measure, analyze it, maybe get an alert when there is deforestation? So that's what Google kind of inspired to build a tool that can take this idea of making this Earth observation data more accessible and allowing people to do this. I can see there's a question on what is Google Earth Pro. So Google Earth Pro is the desktop-based Google Earth, which is again more of a viewer where allow it to explore this data, but it doesn't allow it to do analysis on top of data. And Google Earth Engine is a platform which allows you to do analysis and derive insights. So we'll learn more about that. So how do we build such a platform? So what Google looked at was there's already data out there. Data is not the problem. This is just the screenshot showing the NASA satellites that are in orbit, collecting data for over 4 decades now. And there's so much data out there. Though this is all public domain data, anybody who's tried to work with this data know that it's very hard. It's a lot of challenge to even work with this data. And this is just NASA. There is similar constellation with ESA and ISRO and JAXA. So there's a lot of data out there, but it's hard to use, hard to make sense of it. So how do we, make this easy to work with? So when Google started looking at this problem, they derived inspiration from this book. And this book is by an ex-Microsoft CTO. And he said that, we are in this new paradigm of scientific discovery. The first paradigm was observational, where you observe the surroundings make progress. Then it became theoretical science. Then it was computational science. Now we are in this new paradigm where the scientific progress will happen if we are able to use so-called big data. We have been able to work with these large data sets efficiently, and that's going to result in the new scientific discoveries. And it laid out a plan on how to build the system. And this is the kind of the gist of this book, where it said that when you're dealing with this large amounts of data, it's often more efficient to ask questions where the data is. And in our context, that means that rather than downloading all the data to a computer and trying to analyze it on a computer, it's far more efficient to ask questions where the data is. So if the data is in the cloud, you ask the question in the cloud, which is much more efficient, which allows you to do this rapid iteration analysis. And Earth Engine is kind of implements this plan. So what do? The first thing is you need all the data. And though this data was public domain, a lot of this was not easily accessible. So for example, USGS has all this data, Landsat data that was collected on tapes. So you order some data, somebody would go and fetch those tapes, and maybe a few weeks later you would get them in the FTP link in the email. So this was not readily accessible. So the first thing Google did was get access to all the archival data, and then they built pipelines so that as the new data is collected and published, all gets available into this repository. And you can see the scale of this data is really large. Before I joined Google, I only knew of gigabytes. And then I learned about terabytes. And now we're talking about petabytes. So it's a mind-boggling amount of data that's out there. And again, a lot of the systems are now approaching exabytes of data. So again, this large volume of data, now it's available, it's updated every day. So all the different data sets, Landsat, Sentinel, MODIS, GPM, all the kind of Earth observation data, it's readily accessible. You just specify what you need to use and it's available there. So this is kind of a big deal where you can make this data accessible. But just having this data doesn't solve the problem, because you can have all the data you want, but to do real analysis, you really need to have computation power. When you are analyzing large data, you need a lot of computing resources to churn through that, to analyze it, and to derive insights out of it. So what Google did, this is the kind of a photo showing the one of Google's data centers, and you can think of all your Earth Engine data residing here. All our data is here and co-located with the computation. So Google put a huge amount of computational resources and co-located with data. So when the data is being computed, you don't need to go out to the internet and fetch it. The data is right there. And that means your computation is really fast and you get answers really quickly. So now we have the data, we have the computation, and we can say, hey, now let's do amazing science. But it's not easy, right? You need to know how to translate your workflow and ask the system that I need to do this, go and do this for me. And to use this kind of vast computation resources effectively, you need to write code that is, can be parallelized, run at multiple computers together. You need to be able to manage all that. And scientists, remote sensing folks, we are not system admins. We are not experts in managing this large system. So that's the third pillar of Earth Engine, which is that they give an easy to use API. So API just stands for Application Programming Interface, which is a way to specify how you want your workflows to be done. So as scientists, you may have workflow. I want this image. I want to apply this algorithm. And I want my output as a chart. So how do you translate that and make it run efficiently in the cloud, in a parallel processing environment? So this API is quite simple, where you specify what you need to do, and the system takes care of distributing this in the backend, allocating computing resources, and running this in real time. And all of this is, you don't need to really worry about what goes in the background. You just specify what you need, and the system gives you the answer. And the great part is that this API is available in a variety of platforms. I'm going to do demos to show you that whether you are a Python person or a JavaScript person or an R person, you can use this API in the environment that you like. So now I hope you kind of understand what is Earth Engine. Earth Engine is a collection of data sets which are readily available. It also provides you with computational resources to make effective use of this data. It gives you an API so you can run your computations in a parallel processing environment and get results faster. It also gives you some tools, where you can easily interact with the system, and you can learn about the IDE soon. So when Google built this was about 7-8 years back. They built the system and they said, what's the first problem we should tackle? And this was still not, they said, let's do some problem which helps us internally as well as helps the people outside. And they decided to tackle this problem of clouds. And anybody who's worked with remote sensing data, clouds are a big problem. And especially you are in an equatorial belt where it's perpetually cloudy. This is a screenshot of Landsat 8 scene over Andaman Nicobar Islands, and this is the most cloud-free scene in a year. Now you can imagine, if this is the most cloud-free scene, what the regular scenes look like. And if you're working for this region, you're out of luck. You can't really compare two scenes. You can't really do any useful analysis. So, but the good part is, this is Landsat 8 satellite. Every 16 days, there's a new image taken, and the clouds would move by then. The cloud shadows will move. So you can do the simple analysis where you can take 1 year worth of data for the same region, and for each pixel, you find the median value of a pixel. So the clouds are bright, the cloud shadows are dark. Maybe a median value of pixel would be a cloud-free pixel. If you do this kind of simple analysis, you end up with this. It's a cloud-free composite, and suddenly you have this superpower to see through the clouds, right? And this is not a new thing. This compositing technique has been around for a long time, and people have used it. But what was different now was that Google had access to a system which can process it at scale. So they said, let's try to do this for the entire world. And that's what they did. And they resulted in this, the first ever cloud-free composite of the entire globe at 30-meter resolution. And this is not a real image, right? This is summer everywhere. There's not a single cloud. but it's still a very useful image because it gives you a cloud-free picture of what the planet looks like. And that means now you can, if they did it for a year, they said, let's do it for all the 35 years worth of data. And that's what they did. And that resulted in a product called time-lapse. And what this gives you is it's a zoomable global video where you can explore any place on Earth in a cloud-free, homogenized environment. And you can see how the land cover has changed over the last 35 years. This itself is really useful product because never before you were able to see this kind of deep time series data in a way that is consistent across spatially as well as temporally. So I want to show you some examples, but if you are on your system, I encourage you to go and click this link and check out this system for yourself. This is, if you are working on a project and you want to see how this place has changed over the last 3 decades, this is the easiest and the best way to do it. You can create an animation, understand how the place has changed, and it's really powerful. So I'm going to show you some example. This is deforestation in Assam, and this is the region where the Bodo conflict is going on. The local people are settling down in the forest, the army is setting camp, and over this long time period, 3 decades, you can see this whole forest has been devastated. And this was not possible to see this kind of visually unless you had this yearly cloud-free data. Another kind of use case is urbanization. This is showing development of Greater Noida. And you can see this rivers changing course here. This is one of the, there's a study that was done in Earth Engine where you can actually see how rivers change their courses. And this is, again, with this long time scales, you can see this kind of natural phenomena occurring. And you can see this landscape changing. This is our infamous lake in Bangalore. This lake is often in the news for being one of the most polluted lakes. It often catches fire. And you can kind of see the reason why, right? Over time, the whole city has been built. This ring road has been built by encroaching on the lake bed. And you can see that it really causes problems. You can also see the landscape changes. For example, this is construction of a dam, how an ecosystem is changed. So again, very interesting ways to kind of look at our planet in a different way. I want to quickly show you this site and show you some other places. For example, this is the site we end up, and this is Hyderabad. I'll just search for Hyderabad here, and as you kind of play, you can see this in action, and you can see in Hyderabad, the city. This is the ring road being built. The new airport is coming up at the south of the city, and you can see the whole city expanding towards that. So really useful way to get context and understand how the landscape has changed. So the point of this showing you this was that this is the product like this exists, you can use it. But the larger point here is that this wouldn't have been possible if Earth Engine didn't exist. Because if you had to run this on your own, you would first need to download all this data, and that's almost a petabyte of data. So once you find a storage system that can store all this data, once you finish downloading, you start processing this on even the most powerful computer that you can get on your desktop, and you run this on a single CPU. It's going to take you over 200 years to finish processing that. But because Earth Engine was there, it was able to process this data across a large amount of computing power in a parallel environment. This could be done in just over a day. And the point here is that this power is now available to you. Anybody of you can sign up for Earth Engine and use this, and you can do this yourself. And I teach that this example in my class where you build this example, you build this time lapse, and learn and run this. And if you wish, you can actually do this whole computation yourself. So you have this massive power available to you as scientists to use and leverage this. So how does this work? How does the system work? This is a kind of a big overview, and it's going to get a little clear as I do the demo. But I want you to have this mental picture where the Earth Engine, the stuff in the blue box here, this is, you can imagine that it's a Google data center. And it has got a whole bunch of computers there. All the computers have access to all the data sets, and they know how to run all these basic spatial functions. They can know how to flip, mosaic, do joins, etc. And as a user, you write your request. So this is whichever environment you are working on. You say, I want to do X, and that request gets sent to the Google Earth Engine servers. They distribute this work across all those machines. So if you are requesting, for example, a mosaic, so a small part of the mosaic gets sent to each computer. They all work on it at the same time in parallel. And once they finish processing, all the results are combined, and only the results are sent back to you. And that means if you do some computation which involves downloading or working with terabytes of data, all of that happens in the data center. You don't see all this, you don't need to download work with data set. All you get back is the result. Maybe you just ask for a statistic. So you send a request, all the computation happens, you get back the statistic. So this is a really nice low bandwidth way of interacting and doing your remote sensing workflows. And that results in a workflow which are more real-time interactive. So let's do some demos. I hope my bandwidth cooperates, but it's always fun to see this system in action. So once you sign up for Earth Engine, this is where you land up. This is called the code editor. And this is a kind of integrated environment where you can write some code, click run, and the system now sends whatever code you've written. It translates it to a request that Earth Engine servers can understand, and you get they compute the results and you get the results back. So here I've typed some code, and I click run. So what just happened is that I said I want to get this Landsat scene. So I just specified it by its ID, and the scene got loaded here. And now I want to do compute an NDVI. For those who don't know NDVI, it's a kind of very popular index that shows where the vegetation is. And this is widely used in remote sensing. So let's compute the NDVI. So as I click on it, you can see there are different tiles that came at different times, right? The system sent a request to the server saying, I want to compute NDVI for the scene. The system computed it. I got the NDVI back. And while this was great, it's not really impressive. Say I can do this probably in Python, I could do this in Erdas, I could do it in any other system. But what's now more interesting is that you can say, I don't want just one scene. I want all of Landsat scenes. So here I'm asking, give me all the scenes for year 2017 and do this compositing, where I just take all the scenes and create a median composite out of those scenes. And you can see this is being computed in real time. And as it's being computed, the tiles are flowing in from the system. And whenever I show demos, a lot of people's heart stops, right? Because as a remote sensing person, this is what you spend, months doing this. And now it's just a matter of writing a few lines of code. Now, if I say I want NDVI for the entire world, I can just say, you have this 1 year composer, give me NDVI on that. And you can see the system is now computing this, and the NDVI tiles are flowing in. And you can see slowly the world completes. And you can see this is an interactive real-time system. If I want NDVI for North India, I can just zoom and pan, and the system will get all the scenes, do the computation, and then send me those tiles back to me. Right? And that means I can do this kind of computation interactively. I can change a few things, see my results immediately. Right? And this is what Earth Engine allows you to do, to work on problems without, and I'm not downloading this. I've done this demo from a mobile device. I can actually be in a 3G connection and do this computation. So that means you are able to access this vast amounts of data and computation through very low bandwidth setup. I want to do another demo that shows that this kind of data is not only for say optical data or Earth observation data, you can do other things. So this demo is for, say, you want to do, there's this data set called CHIRPS, which is a precipitation data set. And this is a long 35-year historic record, as well as the current data for rainfall. And this is satellite observations correlated with the ground station, and this data is being made available. So now say you want to compute the deviation of rainfall from long term. And this is a very data intensive operation where you want to say, I am in Bangalore. I want to see what was the rainfall deviation for this one particular point in time versus the long-term 35-year-old average. So for that, I need to first get the 35 years of data, compute its mean, and then get the current data and compare that. But now I can run this. What Earth Engine is doing is fetching the entire 35 hours of data, computing in real time, and just for a point, it's computing this chart, which is the deviation of long-term mean. And this is 2017. 2017 was the record rainfall year in Bangalore. There were floods, and this was also seen as like the highest rainfall in 100 years. And you can see it's kind of how the zero line is the mean, and this is August, where it was 72% higher than the long-term mean. And you could see you can do this computation in almost real time. I could change the point. I could get this. I can say what was the average over a particular basin or a particular district, and I could get this in real time. So again, we're able to work with this deep time series data in a live interactive environment. I will now switch to another way. So this is all JavaScript code, and you can see, though this is written in JavaScript, it's using the Earth Engine API. So you can see how I get images is or e.image collection. So this is done in JavaScript, but say I want to do this in Python. So I want to now show you QGIS, and QGIS has a plugin called Google Earth Engine plugin. Once you install that, you are able to run Google Earth Engine code in QGIS. So once you install it, you can now Google Earth Engine, QGIS can understand Google Earth Engine code. And this is the Python console. And I'm going to load some data locally. So this is the state of Karnataka, and this is the entire state. So what I'm going to show you is that I'm writing some Python code here. This is Python, but again, code looks very similar, right? This is just calling the Earth Engine API. You are just using Earth Engine to specify what you want. So in Python, I'm saying I want to take this layer that I've loaded in QGIS and fetch me 1 year worth of composite data. So this is 2019 year data for this state of Karnataka. You can see the system is taking this request, sending it back to the server, and now the tile got loaded, and tiles are streaming in from Earth Engine. And you can see these tiles are loaded. So now I got my 1 year Landsat 8 composite for the entire state in just a few seconds. And I can do the same demo where I can say I want to compute the NDVI. And as I run this, the system is going to send the request from QGIS to the Earth Engine servers. It's going to compute and get me this NDVI data here. The advantage of using this in QGIS is that now you can combine QGIS's power of cartography. Maybe you just want a map. So you can now create a map, and now without downloading any data, without doing any processing, you got a map of NDVI of the state. And you could, again, combine this with this QGIS's rich Python API to do animations, to do charting, and a bunch of other things. Maybe QGIS is not a thing. You say, I like Python. So you can use Earth Engine from Python. So here's an example. This is a Jupyter notebook. This is an environment where you can run Python code, and a lot of the data scientists are in this environment. And maybe you say, I want to use Earth Engine from there. And you could type very similar code. You can see the code doesn't really change much because all you're using is the Earth Engine API. And here I'm saying the same thing. I'm using a package called GEE map, which allows you to run Earth Engine code and gives you this interactive environment within Python. So again, here I'm loading Sentinel-2 dataset. And I'm saying over Bangalore, load this data and give me an NDVI value. So you can see I can have a map in my Jupyter notebook, and in just a few seconds, I get my NDVI here. So this is just to show that in any environment you are able to do this interactive data exploration using large remote sensing data set. So I'm going to switch back to my presentation now. So again, how does this work? Why this was so fast? What was so different? One is that all of the stuff you saw was based on tiles. So you are not computing the data for the entire region, you are computing tile by tile. And those get distributed in real time to different systems, and they compute that. So when we are doing this small data computation, it's very fast. And the system takes care of sending this to multiple systems and combining them. Another thing is that you are doing this interactive data exploration. The the scale at which you are doing this computation is not the native scale. So we are zoomed out. There's no reason to compute this thing at native 10-meter resolution for Sentinel-2. You can say, the user is zoomed out, I'm going to compute it at a lower resolution. And as you zoom in, all the tiles in your viewport gets computed. So that allows for this interactive system. And there is a batch mode where after you're done processing, let's say I like my results, I want to export it. You can export your results as a GeoTIFF file or as a CSV file or as a shapefile, whichever format it's suitable to you. So Earth Engine is able to take this deep stack of imagery. You can filter it, you can apply computation on it, you can do aggregations, do mosaics, do stats, do charts, and you can do machine learning. Supervised classification is a big use case of Earth Engine, and you can also do now deep learning on cyber imagery using that. So now I'm going to kind of switch gears and show you some applications. And this is going to show you the diversity of the applications and maybe gives you some idea that maybe you are working in this area and you can use Earth Engine to apply it in that. You can actually go to Google Scholar and search for Earth Engine to find a whole bunch of papers. And Earth Engine has emerged as the platform of choice for all the researchers. And there are new papers being published every month that use Earth Engine as the platform. And the reason a lot of people like it because it's reproducible science. So as you're working on a problem, all the code, all the data is right there. You can share your code with the reviewers. You can share your code with the readers, and you can reproduce the exact results. You can do massive global scale problems. Earlier, now the research work was focused on a small area because it was not possible to run this computation. But with Earth Engine, you're able to do this at a global scale. So just search for Earth Engine and you'll find a whole bunch of research papers. It's also a great way to learn because a lot of paper also share the code. So one of my pro tips is that if somebody asks me, how do I solve this? I would say, go find a paper that's using Earth Engine and you might find a code snippet that does exactly that. So you can take that and adopt that. Another thing that Earth Engine is quite popular is that when you spend all your time doing this research, you really want to share your results. You want to share your data, you want to share your results with the stakeholders. And this is often very difficult. But Earth Engine allows you to create this interactive apps right to the system without you knowing anything about web applications or front-end programming. You can build this interactive apps that allow stakeholders to play with the data and change things and see how the data works. So this is a great way to communicate and share your results. So I'm going to show some apps that are for researchers in various domains. So again, the power of Earth Engine is that you need not be a domain expert. You can be a user, you can be an end user of this, the results of this platform and still derive a lot of value out of it. So the first application I'm showing is called Surface Water Explorer. This is a site done in collaboration with UN. It's looking at the SDG 661, which is the Sustainable Development Goals. And this goal talks about preserving the surface water, degradation of surface water. And as we are looking to preserve our planet, we need to know how our surface water is changing over time. And whatever measures we put in place, are they helping our environment? So this is an application which is powered by Earth Engine. You can see this is all done in Earth Engine. You can say, I want to load some admin data, and maybe I'm a water manager in Karnataka, and say, we have put some measures in place. Let's see how our state is doing in terms of preserving the surface water. I can click on it, and it's now doing real-time analysis of this the data, Landsat data over the last 30 years, and it can say how the annual surface water is changing over Karnataka. And you can see it's been declining over the past few years. And you also see how much water is seasonal, how much is non-seasonal water, permanent water. And again, this helps people do this at various scales. You can actually look at it at different levels. You can look at a basin level, you can look at a district level. And this is a global data set. And this is a peer-reviewed scientific study, which the results of which are published, and you can explore them using Google Earth Engine. Another one I want to show is this idea of urban heat islands, where there's this notion that in urban areas, due to urbanization, there is a marked difference between the temperatures of the urban and non-urban environment, and that's called the urban heat island. And again, this is a global study that was done using Earth Engine. The results are available through this app. And this, you can explore this in detail. This is done using the MODIS data. And you can go anywhere. And I'm looking at Bangalore, which is where I am. And you can see this data where the daytime surface temperature in the urban areas is higher than the non-urban areas. And as I click on anywhere, I can explore how this has changed over time. You can say there is a difference between almost 1.3 degrees at night between urban versus non-urban areas. But more importantly, I can see how this has changed over time and what's the variability season-wise, which helps you understand. As a scientist, you've done this study, now you can share this with your stakeholders and decision makers, and you can look at this data and use it to make changes. Coming to another application, this is a really very impressive study which looked at tiger reserves. And the idea was that tiger reserves are one of the most protected regions in India, and they have a lot of resources allocated to them. So the study was looking at historic data over 1984 to 2012, and they looked at whether once a particular reserve was declared a tiger reserve, did it impact? How did it impact the vegetation? Did the vegetation green cover improve or did it decline? And they built this app to show the result of the study. Now you can take any tiger reserve and explore this data in this interactive environment where you can see on the left side is whether it improved or whether it declined, whether declaring the particular reserve, tiger reserve helped or harmed. And you can look at this in detail and explore this. And this was a study done by CWS in Bangalore. And there's a news article you can read which shows and talks about this, whatever the results that they found. Another application which I'm very fond of is this thing called Global Forest Watch. And this is again a global system that is built using Earth Engine. And what this allows you to do is to monitor the forest in real time. As a person who's interested in conserving forest, you can go and sign up with the system and say, this is my area of interest. And as a new images are collected every week, it runs a comparison against the previous imagery. And if it detects a deforestation, it's an alert. So now you're able to catch deforestation in real time. And this is an example in Peru, where you can see at the top of the image here that there's an illegal road being constructed in the forest. And through the system, the people who were responsible for protecting this region, they were able to get an alert and they were able to catch people who were building this. If the system was not in place, they would have probably known about this years after all the damage was done. And this kind of system allows you to do it. And to do this in real time, you need a system that can crunch through large amounts of data in real time. And that's what Earth Engine allows you to do such things. This was another study done by NCF in Karnataka, and they were interested in looking at the area burnt after forest fires. And they used this common technique called normalized burn ratio, which detects the burnt pixels from satellite imagery. But because it was done in Earth Engine, they were able to get the data for the entire state and do this at a scalable way. Normally, this is done at a particular reserve area or a particular small area, but using this cloud-free composites, they were able to compare before and after imagery, and they were able to detect which pixels were burned. They were able to estimate how much area in the state was burned. And again, this is something that can be done by anybody using the system. And as you are trying to mitigate the risk of forest fires, this helps you understand and monitor your forests. This was another study done at A-Tree out of Bangalore. And they were looking at how forest cover is changed in different reserves. And they were looking at what they did was they took long time series data, did a supervised classification, and understood how each class changed over this time. And you can see the seasonal trend as well as the long-term trends around this. And this was all done in Earth Engine, and then you can interactively explore and do these results. this was a study using the SAR data, the radar data, where this was done to visualize the damage done by the Kerala floods in 2018. And the idea is that Earth Engine can also has access to the Sentinel-1 SAR data. So using Earth Engine, we were able to compare the before and after imagery. And this app was built for people to explore and understand where the flooding has happened, and the red pixels here are where the population is. So again, you can overlay population data and you can say how much population is affected, where should we focus our effort. And because it's a cloud-based system, this can be done in real time. Once you have the system in place, the next time a flooding happens, as soon as a new satellite data is available, you can get the results. And that means you are able to respond to these disasters in a faster way. IIT Bombay does a lot of excellent work with SAR data, and they have published numerous studies using SAR data effectively using Google Earth Engine. You can read this paper as well as their studies, and they use Earth Engine a lot in their lab, in the teaching, as well as for doing research. This was a recent app done by International Water Management Institute out of Colombo, and they did this global crop area monitoring, where they were concerned that due to lockdown, due to coronavirus, now the harvest will go to waste, and they built this app using the MODIS data, MODIS EVI, and detecting which pixels were ready for harvest, and they could see that these are the areas which will be harvested soon, and this is where the attention should be given to help those farmers take this produce to the market. So again, this is a global app you can explore and see a use case of this kind of analysis. There is a lot of attention now to deep learning, and Google Earth Engine being a cloud platform, it's closely integrated with Google's another cloud platform called TensorFlow. And if you have done any deep learning or machine learning, you know TensorFlow is an open source library that Google has released, and it works closely with Earth Engine. So if you're doing deep learning, first thing, you need a lot of training data. So Google Earth Engine helps you get this training data. Maybe you are doing, say, a land cover classification. You want examples of different land use classes, and you want those image chips. So how do you generate that? And that's a very painful process. But Earth Engine, since it has access to all this data, you can actually get those training data and export it to cloud storage, Google's cloud storage, where Google's TensorFlow AI platform can read that, you can build a neural network to learn from it, and then once it's ready, you can import this model in Earth Engine and do predictions. So this allows you to now scale your training as well as prediction data for Earth observation. And you can use Earth Engine to whatever the public domain data is available, or if you have access to your own high resolution data, you can upload it privately to Earth Engine and run this kind of system. And that's where a lot of the companies who are doing this intelligent monitoring, they are using Earth Engine to an AI platform to work on high resolution imagery. So I'm at the last segment where hopefully I've got you excited enough, and as a remote sensing person, you are now interested in, say, I want to learn Earth Engine. This sounds exciting. It will help me save some time. I can do some interesting work. What are your steps? How do you learn this? And this is where I spend a lot of time at Google teaching people to do this. I'm doing right now, I'm training a lot of people on the system. So this is a subject that I've, is very close to my heart, and I want to point you to some resources that help you get started. So all of you have access to this presentation, so you can look at this link later, but I want to show you different resources that I've added here. So the first one is the official documentation. So this is where all the official documentation is present. There's a lot of effort that is gone in to create this and maintain this. And the first tab here on top is the guides. So these are step-by-step guide with the code example on different things. So say I want to do, if you're interested in, say, I want to do raster to vector conversion. How do I do that in my thinking? And you can come to this guide, and it takes you to some sample data, gives you some code sample, and then shows you how to do this. So again, if you know a task that you want to do, this is a great place to say, how do I do that? And you can search for that. There is also a community here, which is, there are tutorials written by different scientists who are doing their work in their own area. So this is, if you want to say, I want to do Modis NDVI time series animation. And so somebody has done this and published this. You can see, how do I create an animation like this? And you can go and learn about this. And there are code samples here. You can copy paste and use this. There are educational resources, which I'll come to that later. But again, a lot of rich resources here. I also want to show you that if you're new to the platform, you may want to learn about the basic programming task. How does JavaScript look like? How do I do basic things like find an image, filter it, export it? So again, as there's a get started guide which helps you do this. And then there is an API overview. So again, one thing to remember as you're learning Earth Engine is that you are not learning a particular language. You're not learning JavaScript. You're not learning Python. You're learning the Earth Engine API. And once you learn this, the code in whichever language you want, it's quite simple. It's actually, if you want to convert from JavaScript to Python, it's actually a copy paste. You just remove a few things and it becomes Python code. So don't let the language be a barrier. I always recommend you start with the code editor because it's a nice environment. Without an installation, you can go and type some code and see the results immediately. It's very easy to get started. But a lot of people, including me, have a hatred towards JavaScript. And it took me a long time to kind of come to terms with like I'm coding in JavaScript because I say I'm a Python person, I don't learn JavaScript. But the sooner you come to realize that you are not really learning JavaScript, you're learning Earth Engine API. And JavaScript, you just need to know enough JavaScript to say, how do I write a function? How do I call this API, etc. So I would suggest start the code editor, learn the basics of JavaScript, and then learn the Earth Engine API, which is the API tutorial here, which shows you how to really use the API to do the remote sensing task. And there are machine learning stuff, etc. You can learn from here. The other useful resource is the data catalog itself. And all your workflow would be using some data set. So maybe you say, I want to know what data is available in Earth Engine. So if you're working surface temperature, climate, imagery, so maybe you say, I want to use Modis data. Let's see what's available in Earth Engine. And these are all the different data sets that are available. You can look at each of them and see how to use them. And you learn more about this data set. And each of this data set will have this code snippet, which allows you to load this data, visualize it. So this is kind of a very useful thing there. You know what data set you want. So when you find this data, just open this in code editor, you have immediately something you can play with. You can understand the data structure, you can see how it works, and then you can kind of change things to the data range you want, the area you want, and you can quickly arrive at something that is useful to you. And that's a good way to get started. This is also a useful thing that you will need help when because as you're learning programming, you're trying to solve a problem, you get stuck. So this is a very useful page where it says what to do. I have a question. Where should I ask the question? So if you have a technical questions like I'm trying to code this and getting an error, what should I do? So there is a site where you can post this Stack Exchange, GIS Stack Exchange, which is where you post a technical question. There's a community of users, including people from Google, who will help you solve that. If you have more discussion questions where it's like, I'm trying to solve this, but I don't know what's the right approach. So the mailing list is a great place. So this is the Google Earth Developer Forum. So as you sign up for Earth Engine, you'll get an invitation to join this forum. And this is a really rich resource for you to find useful things, ask questions. And the great thing about this is that all the Earth Engine users are here, they're active. And when they will find domain experts, say you're working on climate change and your data, a question that is very specific to a data set. And you ask that, you'll find another climate change scientist, maybe is working from Europe and they've encountered the same problem, they can give guidance. So it's a great community. I'm also very active. I've answered a lot of questions there. There are people from Google who answer questions there. So definitely I encourage you to join this community and look at it, post for help. It's also a very useful resource because last 8 years worth of questions are all here. So, and oftentimes when you ask a question, you get a code as a result back. So you can search for, I want to do, say, I want to do, say, We'll do urban heat island. And you can see a lot of people will ask that. I want to do linear regression against that. How do I do that? And you can see, people will ask, questions, and then somebody will share the code. So somebody say, I wrote this code, and then when you click on this, you will get the code. So again, when you're encounter a problem, search the forum, find an answer. If you can't, post a question. It's a very welcoming forum. A lot of people will help you out. There's a page on case studies. Maybe you are still deciding, how can I really use this? So there are a lot of case studies that Google has published over the years on variety of topics and how other people have used this. So this is similar to what I presented today, but it's a much more diverse and global perspective. So you can learn about this and see how people have used that. This is another list here compiled by the community, which is a curated list of learning resources. And this is really useful where anytime somebody writes a tutorial on the web or a useful video is published, people go and add it here. And this is a really powerful resource where there's a lot of resources here, and you can discover a lot of learning material here. So you can look at this here and see the different tutorials, etc. The last one I want to show you is I also maintain a repository. So if you click this link and if you're signed up for Earth Engine, you'll get in your left side, this is where the code is stored. You'll get a repository called under the reader section here called demo, which is done by me. So I maintain a lot of useful code whenever I answer a question and I feel this is useful for somebody, I actually add it here. So I maintain this, and you might find useful code snippets that can help you adapt and using your system. So you can add this, then you can have I do a lot of work on the water resources side, so I have a bunch of water resources demos which you can use, and the stuff I showed, red phone anomaly, you want to see what SAR, water detection using central data. So I have all the code here. You can just freely use it, adapt for your use case. So we're doing good on time. I have a few more minutes to go, and then we'll open it up for questions. The last bit I want to present is teaching. So you are at an institute, you are a remote sensing instructor, and you said, this sounds interesting. I want to prepare my students to this kind of new way of doing remote sensing. I'm excited about it. What should I do? So why should you use Earth Engine? And what Earth Engine enables you is let the technology be aside. It just changes your focus, where you are not teaching students how to do data processing. You are actually spending more time doing discussions and see how to solve a problem. And it again frees you up from this IT setups where you are lab, you're maintaining machines, you are doing this long data processing tasks, and all of this is kind of taken to the cloud. It's hosted. It's a free system. Anybody can sign up. The students can use it. You can use it, and you can do experimentation. So when we're teaching, I love doing that, because when I can say, what happens if you change that? Some students ask, and I said, go and do it. And they are able to just go change a bit of the code, and they can see the result for themselves. And this really opens up a lot of people's learning, where now if you're really curious, you can quickly ask questions, get results, and it allows you to more iterative learning. Another kind of useful thing from the industry perspective is that I showed you that you are writing code, you are in this environment, Jupyter environment, and this is the environment that industry uses. Non-industry data science folks use the same environment. So when you train your students, you use this environment. So you're training them how to write code, first not be afraid of coding, learning to code, doing data science in the same environment that the industry is there. So it prepares the students better suited for the industry. And again, it's a fully open system where everything in Earth Engine, whatever you do, can be exported as a geotiff, as a shapefile, to be used in another system. So again, it ties in with your other thing. Maybe you are teaching them statistical analysis using R, and you want to do, say, there was a recent project somebody asked where they're trying to correlate the night lights data set versus GDP. And if you're doing this kind of correlation, you need to know for each of the admin unit, what has been the change in the night lights and what has been the change in GDP. And once you can actually compute that in Earth Engine and export this as a CSV file, take it to R, and do your regression and use it. So again, you can use the tools that you are using, but use Earth Engine for doing the heavy lifting on the data processing side. There are a lot of resources for higher education and short training. So a lot of the universities who are adopting this in their curriculum, they are sharing the resources for other educators. So this is the link on the user guide where you can see there are code labs that people have shared in various language, and there are lectures that uses that. So again, all this material is available. So as an instructor, you can take this, adopt it, and use that. And if you're doing short trainings, this is what mostly the stuff that I do, where I'm doing a weekend training or a short training. There are a lot of instructors who have also shared those resources. And you can say, maybe I'm not ready to do the full-fledged course, but it would be nice to expose my students to a short training. And you can take the resources here, and the resources which are focused on a particular domain, like water resources or forestry, or more generic ones, and those are shared here. You can use and adopt those for the needs. So that's it. This is the stuff I had to show you. If you've not got your presentation yet, this is the link. It's bit.ly/IEEE-GRSS/EE. If you go to this link, you'll get the full slides. The slides have speaker notes at the bottom, so which have got more context on the slide and the links to the material. So if you all the demos, all the stuff I shared is available here. Feel free to contact me. I'm Ujaval at spatialthoughts.com. I'm also on Twitter, and you can feel free to visit my site and email me. So now let's open up for questions. This is the part I love the most. I want to hear from you. If you have questions, if you are interested in using it but not sure where to start, I would love to answer that. So I'm going to stop sharing the screen and we'll take some questions.
Yeah.
Yeah.
Can you hear the question? Yeah, so you can
Yes.
see the questions, or I for you. So the question on which
Yeah, I think
satellite
we'll
Google is
just go
using
through
for
them
mapping.
from the beginning.
Yeah.
Yeah. So this is kind of a different topic than what we discussed, right? So the mapping that you see
Right.
on Google Maps is done, but I can answer that. I think it would be useful for people to know. So the satellite that you're probably referring to is what you see on Google Earth and Google Maps, right? So the satellite imagery that you see. And that imagery is a high resolution imagery. Google doesn't have a satellite. They license this data from different providers. For example, Maxar, they have WorldView 2, WorldView 3 satellites. They also license data from Airbus, and they also license data from Planet Labs, SkySat. So there are a bunch of satellites, high resolution satellites, that license data and published on maps and Earth. But that high res data, since Google doesn't own it, it's not public domain. It's not available in Earth Engine. So you can't run your machine learning on that. You can't use them because everything in Earth Engine catalog, what is available, that is all completely open public domain. If you go and purchase this satellite imagery from Maxar, you can actually upload it privately to Earth Engine and use it with your other data sets. So you are able to use that privately, but you need to purchase and use that.
Okay. So there's a message which I got private message. Be an expert in these applications. What are your suggestions? How can I get a career in this field? I think they should just join your course, maybe, right, Ujjwal?
No, I would love to answer that. I think this is something that I've given a lot of thought, and that's the reason I'm doing what I'm doing. So I would love to kind of give more kind of broader guidance to people who are interested in this field. So as you know, if you're already in a part of a remote sensing program, or you're studying geomatics or GIS, that's a good first step. And as you've seen that the industry has kind of transformed from a pure desktop-based, a point-and-click kind of environment where the role of a GIS or remote sensing person was to just, click buttons, develop some workflow and get results. To the new careers are in more of, how do you take these large amounts of data, either build pipelines, do some meaningful insights out of this, and do this in scale. And the tools for this are that you need are, you need to be proficient at programming. So, Python is a great programming language for geospatial. So my first suggestion would be, start getting comfortable in Python, learn the basics, apply it, all the GIS like QGIS, ArcGIS, you can apply Python there. You can start applying to Earth Engine, etc. And once you learn programming, you can say, find a problem that you're excited about. I think that's a more important thing, that what excites you. Because as you're working through programming and learning this, it's a challenging thing to do. So see what you're excited about. See, you are really passionate about conservation and forests, and then find a problem, find an area that you're passionate about, and then start applying it there. Because this is a technology. It's it by itself it's not very powerful. It's powerful only when you apply it to some problem. So find a problem you're passionate about, learn programming, and apply this.
Right. Thanks. It's a question on UAS, that is unmanned aerial systems. So they work on this work on remote sensing from UAS. Are there tools in Google Earth to fuse geotagged UAV data with satellite imagery? Can I fuse geotagged UAV data with Google Earth satellite imagery? The objective is to obtain sub-decimeter multispectral data by fusing UAV and satellite imagery, basically the equivalent of pan sharpening.
So Google Earth Engine doesn't have tools for doing this kind of creating orthomosaics from individual satellite images. You need to use some other software, like ODM, Open Drone Map is an open source software, or Pittsburgh or something like that. Once you have your orthomosaics, you can actually upload them to Earth Engine, and then you can fuse them with the satellite imagery that's available. You can do pan sharpening there, etc. So Google Earth Engine understands orthomosaics. It doesn't understand kind of individual untagged, unreferenced data. So currently there are no tools. So once you have an orthomosaic, you can upload it. Once you have a DEMs, you can upload and do some analysis.
Okay. Anne, can we detect paddy fields in GEE?
Yeah, I pointed you to one study. Yeah. So if you look at the slide, slide 41, I have given a study that was done by IIT Bombay, and there's a link to the paper, and you can look at that and see how we can detect paddy.
Okay, using SAR, is it?
Yes.
Would be. Yeah. Okay. The same person as us, as a basic learner, where do you think I should start from getting to know GE? I start with classifying. So is there something? I guess you have already answered that, right? So
yeah.
on
So
Python
supervised
and get.
classification. Yeah. So I think supervised classification, I didn't cover that, but let me just quickly show you where you can learn supervised classification. So that's one of the use cases of GE. So if you have a supervised classification problem, you can go to the Earth Engine user guide, and on the guides, there is a guide on supervised classification.
Okay.
So supervised classification, and this goes through the steps that you need to do supervised classification. And there's a video also which goes through that. So again, the best way to learn a system like Earth Engine is like you take a problem that you have. So I want to do supervised classification, and then you start learning and try to implement that. You'll for sure encounter errors and probably get stuck. Seek help in the resources I sent you, and once you kind of get comfortable, then take on more challenging problems. The supervised classification is a great thing to start with, because you can do interactive stuff, change a parameter, see how classification changes, etc.
Okay. Are these specific images? I mean, this is a question I'm asking. So, are there data types that it can handle?
These are very kind of tuned towards the satellite imagery. So if you have a gridded data, so it's not specific imagery, but you need a georeference gridded data. So that's what Earth Engine understands. So if you can, so there are been analysis, for example, done on, there's a really nice study on global friction surface. So you kind of determine each pixel, what's the kind of travel cost, and you can do a bunch of analysis on that. So you can get any data into a gridded format, then Earth Engine can understand.
Okay. Okay. How How is the NDVI computed for whole India even when we have selected only one data set? Can we download this computed data?
Yes.
That's the
So
question.
if you look at the code link, it's shared in the slide. The code link for doing the global or India-wide NDVI is saying that you get all the data, all the Landsat scenes, and then do a composite. So you take a year worth of data and then do a composite of that, and then compute NDVI. So once you get that composite image, which is India-wide or global image, and then you are able to compute NDVI just by doing the ratio of the infrared and the wideband. And yes, you can download so all the results of Earth Engine you can export. So there's a once you are satisfied that this is what I need to do, you say export this image to my Google Drive. You start the export process, specify what resolution you want to export, what projection you want, and that will get process will start. You can close Earth Engine, sleep in the morning when you come. Maybe the whole India's geotiff is waiting for you in Google Drive. You can download it and use it in QGIS or ArcGIS or whatever.
Okay. The next question is, how does the EE commercial license program look like?
Yeah, so this has been a kind of long-term thing, like, where people say it's a free system. How does Google monetize it? Will it, maybe this is a teaser thing. At some point, they'll start charging us money for it. So they've launched a kind of a early version of the commercial program. And what it looks like currently is that it's integrated with the Google Cloud. So if you're familiar with the cloud offerings, say Amazon or Google's cloud, the idea is like pay per use. So you sign up for Google Cloud, and your Earth Engine usage is tied to your Google Cloud ID. And then currently, again, there is no charge. As a commercial customer, you are able to sign up for Google Cloud and Google Earth Engine. You can run your things. And once they come up with a monetization plan, then they would say, by doing this, you use this much computation resources, and this is the charge. So it's again going to be per computation. And as I understand, there's always going to be a free tier for people like who are using for non-commercial use, like scientists and researchers. But again, that's not announced. So far, it's completely free for non-commercial use. And if you're a commercial user, you can sign up for the Google Cloud and be part of the early beta program for that.
Okay. There are two questions. Is Earth Engine and analysis based on it have a commercial approach, or is it only for research or educational usage? I think you sort of answered it right now. In the Indian context, can the Earth Engine analyze data? Can the analyzed data be published online? In India, is that possible? I guess this is referring to maybe the data sharing part. Yeah.
Yes. So one thing that we need to be aware of that Earth Engine is actually being used at a lot of our government agencies, and they use it with the public domain data. For example, I've trained folks at NRSC. I've trained folks at Manavis Crop Forecasting Center, and they're using it, but they are using it with the public domain data. So, for example, if you are doing drought mapping and drought monitoring, even our drought mapping manual for India says that use MODIS data. And this is what you do. So when you're doing this, you can use MODIS data. This allows you to use MODIS data much more effectively. And if you are doing this with MODIS data, sure, you are able to publish this data. But if you are using, say, the data from NRSC, our Indian satellite data, their terms of service says you can't upload it to a cloud service. So that means if you get some data from NRSC, you are not able to use this in a cloud system like Earth Engine. So what I've seen people do it is that the parts of your analysis that is done using public domain data, you do an Earth Engine, export the results, combine it with the data, and the data sharing. Again, you need to be aware of the policies. You can't our policies for India says you can't share high resolution data, but all the data in Earth Engine that's available is medium resolution, so 10 meters and above. So that means you are able to whatever you do in Earth Engine, you are surely able to do this. And another thing that there's a earthengine.co.in version, which is what you should use as an Indian user, which complies with the policies of the government.
Okay. So there's a question on employment at Google. I'll come to that in a little bit. There's another question. Is daily wind direction data, satellite-based one, available for a place on Google Engine, Google Earth?
Okay. So
Is
I
the
know that
daily wind direction data, which is satellite-based, available? Yeah.
Yeah, so this is I know that, there's ECMF data that's available. I've used it in QGIS for doing this. I don't know yet it's available, nothing. So what I'm going to do is I'm going to search for wind in the data catalog. So I'm going to learn with you and see if it's available or not. So this is something that, you can see what are the kind of wind data that's available. So yeah, there's a ERA5 data. It's available. This monthly aggregate data, it's available. And you can read about what those are. This is a 10-meter V component of the wind, U and V component. So you are able to get this daily and use this. And if you want to use this, just copy this code snippet and use that. Right. So this data catalog is really useful. There is also, for example, if you need a data that's not in Earth Engine, and you don't see it right now, but it's a public domain data. So there is if you search in the help section, there is a public kind of a wish list where you can say, I want this data to be in Earth Engine. And as more users vote on it, they will actually put it in Earth Engine. So again, you can see what data set they're ingesting and working on that. So definitely check out. You can just use search and find out.
Okay. Now there's one more question on the NDVI and all of that. So how do you calculate precipitation, NDVI, soil moisture anomaly, and GEE?
Yeah. So the idea for doing this anomaly is that you need a long-term view and you need the current data. So for precipitation, what the example that I showed you, it shows you exactly how you can load this entire data set and compute a mean of that. And then you can get the latest data and do a subtraction. So the computation is quite simple. But what the power of Earth Engine is that you are able to do this computation real time using this very deep time series. And you can do, for example, I can compute
Okay.
that for Karnataka, what was the yearly deviation rainfall? And that would just take me 5 minutes, and I'll get a CSV file of that. Right. So that's the kind of useful thing. The algorithms remain the same. You need just to implement them in Earth Engine, and you'll find plenty of examples of doing that. Just go to the user forum, search for rainfall deviation, you'll find code snippet. And same goes for soil moisture and
Okay. The next question is, does the Earth Engine support stereo satellite imagery analysis and also allow loading of 3D data formats like LiDAR and thus provide a fusion-based analysis? Okay,
Yeah,
would be of
as far as I
interest to
know,
me
there is
also.
as far as I know, there is no support for stereo image processing. LiDAR data is not supported. So again, from LiDAR, you generate your orthomosaics, your DNs, and you upload that. Even
Yeah.
the 3D stereo base, I don't think it's available. There are people who tried kind of doing taken multiple satellite data and trying to derive kind of based on the view angle, trying to derive some stereo stuff, but it's not supported out of the box.
Okay. Hello, Ujjwal.
Yeah, yeah.
Yeah. Okay. Sorry, we missed the last part. I'm guessing. Okay, so last question is, what is the meaning of mesoscale analysis?
Not sure. I would say you should just search it. Google search, which I would do.
Sorry, Ujjwal, we can't hear you, I think.
Yeah, so I just said, yeah, I'm not aware of what is mesoscale. Anyways, sorry.
Okay, all right. Okay. Yeah, the next one is an interesting question. Does Google prefer giving jobs for GIS background students?
Yeah, so the over time, what has happened is that the industry has changed, right? When I joined almost 15 years back, they needed GIS people because they were building maps, they were doing the kind of data processing, and they needed people who understand GIS data. But you can see the kind of work that involves now is so the Earth Engine team is essentially doing remote sensing, but what they are doing is, for example, the jobs that are available, it says, can you take this, wind data that's published daily? Can you build a pipeline to download that, process it, and ingest into Earth Engine in a scalable way? Can you write a pipeline that can ingest a terabyte of data every day? And if you're a good programmer who can understand it, definitely there's a job for you. But if you just say, I know ArcGIS and I know QGIS, or I can operate, there is no job for that because the requirement has changed from doing that work to building a platform there. So, and I would suggest, and that's the same thing for, say, a lot of interesting work is happening at Facebook, Amazon. Amazon is hiring like hundreds of people for the geospatial team. Uber, Swiggy, all of these people are hiring geospatial people, but the skills they require are people who can work with this massive amounts of data, can make sense of it, and use them effectively. So your knowledge is really helpful, but I think we need to build on that, build skills in programming and applying those to solve problems there, and then you'll have a job for sure.
Thank you so much, Ujjwal. There aren't any more questions here. We'll post all the things about your talk and the talk slide and everything. Post it on the event website, and the talk
Sure.
will also be uploaded soon. Yeah. Thank you so much for the exciting talk. And a big
Thank you for hosting me.
round of
And
applause
thank you for,
to you. Yeah. Thank you. Yeah.
thank you, everyone. And a great discussion. Definitely reach out to me if you need help or need more info. I'll be happy to answer. Thank you.
Yeah. Definitely. Yeah. Definitely. Yeah. That's great. Thank you so much. Yeah.
Thank you as well.
Thank you, sir.
Usual, it is excellent. Thank you for giving such a nice talk. And I should also thank Jaya Madam bringing such a nice talk in our Bhumandal series. And
Yeah, I should thank Gurudatta for bringing a great talk here.
I think he should be ready for a senior membership, and he's already not the senior member.
Sure.
I think we should try making him senior member. Yeah, I think he has 10 years of professional experience. Good, good. We will meet sometime probably when things improve. We will meet sometime, and there are many number of opportunities. And of late, actually, we got a 100 crores project here in our institute,
Okay.
and it is about technology innovation hub to develop technology innovation hub. And they said Indian Statistical Institute is famous for its data sciences team.
Okay.
And for data science, they have given this TAH to Indian Statistical Institute. And because there are 10 members, and I am one of those 10 members, and they said I have to write a proposal about ICPS, geo cyber physical systems. I think you must have heard about it. And we have to decide there its X surfaces with full of physical systems, and is there a way that we can really model and make predictions, and micro level to the macro level physical systems. I think we are still working on the modalities, and it would be nice. We will meet once, and then there's a lot of overlaps in our interests.
Sure, definitely. I would love to.
So good to hear you, and we'll meet sometime.
Sure.
Thank you. Thank you.
Thank you so much. Yeah. Thank you everybody for
Thank you, ma'am.
attending
Bye-bye.
the talk on a Friday evening. And yeah, thanks. Yeah.
Thank you.
It's a talk now. Thank you. We'll take care.